All right, welcome. I'm going to speak today about avoiding spaghetti by making ravioli. I realized my mistake here. I should explicitly call it spaghetti code, so hopefully no one here is expecting some chef's advice, but we'll look into code. But before I get started, I have to get something out of my system. Hopefully this works. But there's a song that's living rent-free in my mind and has been for the last 14 years, I think, which also inspired some of the topics of this talk. So I'll start by trying to play a video. And it would be interesting to see, in fact, if other people recognize the song as well. So afterwards, I'll do we'll do a poll to see if anyone recognizes. So let's cross our fingers for this to work. First this.
Your client-side JavaScript is starting to mold. It's starting to resemble a bad spaghetti code. And it is time to add structure, but it won't take too long. Gotta get your truth out of the DOM. Take your data in the models that you cannot lose. We'll render out your models with the help of the views. And if you don't want your JavaScript to end up like a mess, it's time for the anatomy of Backbone.js at code school.
That's memories for me at least. So, has anyone heard that song before? 3, 4, 5 people. So this was the introduction for a course, I think it's 2010 or something, when Backbone.js was introduced. But the important part here, I think, is that first of all, it mentions spaghetti code as a concept that's been talked a lot about for several years, and it's still relevant. I don't feel like we talk about the concept as much anymore, but it's still as relevant. And the relevancy is also explicit in the song itself, because it's talk about how to structure. So it's this ever-moving goal of reducing some unclear code, and this is my take 15, 14 years later, and then to avoid spaghetti by making ravioli. So what characteristics are there to spaghetti code, and to spaghetti specifically? But it's impossible to take a spaghetti individually without having to think about the entire spaghetti bowl. So looking at the spaghetti bowl, it's entirely a mess. It's just a ball of one entity. It's hard to decipher the individual parts. It's impossible to eat spaghetti without making a mess. So how does that relate to code? I think spaghetti code is the same way. It's hard to decipher the individual parts. It's hard to take in the spaghetti code without making a mess. And I think this is interesting because this isn't the only form of pasta code there is. I like to think of fettuccine code as a separate concept. So fettuccine code is initially very structured, and it feels like a structured thing, but when setting it into the real world and when boiling or take it into production, it also degrades to the same part as spaghetti. So it's something that feels like it's structured, but in reality it isn't structured, and it's just as messy as spaghetti code. And I think fettuccine code is the same way. I think it's optimized for the ease of writing instead of thinking on structuring over time. So I realized that ravioli is the perfect meal because it's not individual just pasta, it's an entire meal encapsulated in itself. So in that way, it's also easy to consume. It stays in the same shape forever. Yes, it grows by adding some liquid or something, but the shape itself is the same as when you make it. And ravioli code is the same way. So it encapsulates the interesting parts, and keeping all other parts separated. So in ravioli code, it's easy to just take one part without having to handle the entirety of the bowl of ravioli. So what separates the ravioli system from spaghetti code? First of all, it's easier to see where something begins and something ends. So it's easy to just remove one part of it, like a ravioli. Our ravioli system is a clear path from top to bottom, and as such is easier to navigate than spaghetti code. It's not always the easiest to create, but it's structurally simple and it's consistent. A ravioli system is more evolvable over time as it focuses on communicating over time. So we'll look into more of this, but first a note on programming itself. So programming is communication. It's easy to think of it as human-to-machine communication, but it's just the beginning and the easiest part of it, I think. So expressing some sort of understanding of a domain, converting that into a system that communicates the domain itself in an explicit manner, that's the form of communication. It's also an interface over time. So it stands over time and it stands across people. So look into it in the future. It has an entirely different meaning than when you're writing it. It's also a communication to yourself and to others. So it's explicit communication that has to bear some type of meaning across not only what you write, but how it reads. And that's an ultimate fact about code, right? Because it's always just written once, but it's always then read more times than it's written. Because, yeah, obviously. So focusing on what happens to code over time is more important if you follow that logic. And I also think that's the reason why focusing on productivity while writing something, I think that misses the point instead of focusing on productivity over time of the entire system instead of just writing. So to achieve a ravioli system, we will not focusing on code, on writing the code and optimizing that. We'll not optimize like for the open-close principle where open to change is big. That's not what we're optimizing for, but we'll optimize code for deletion or removed. So having a system that's optimized for deletion, we always feel safe to remove something without fearing regression or fearing how it affects our system while removing it. So that's the most fundamental part. You will often, I think, hear of this as easy to reason about, often while reading code. Oh yeah, that's easy to reason about. But we'll try to go beyond empty statements and explore why, what, and some of how. But trying to focus more on understanding the principles behind it and not dogmatic rules that we're used to with clean code talks. So we'll start with the optimized for deletion as the fundamental principle, as I mentioned. And the reason is, this is something we hear regularly, I think. So the best code is the code never written, but I like my job, so I need to write some code at some point. So I like to also say that next best code is the code that we dare to delete. And to look into that, I think we also need to recognize that complexity exists. But there's a difference between unintended complexity and intended complexity. Because some code is complex by a reason, but that should be the code that's operating on a complex domain. So in that way, it's intended complexity, but things like introducing some sort of dependencies or introducing libraries that handle our code is by definition just unintended complexity because you're managing your code itself. So we're trying to limit the amount of unintended complexity instead of thinking that complexity doesn't exist at all. But in my mind, there are two ways to handle unintended complexity. It's abstract and isolate and remove. So we'll look more into those as we go along. The first example, I think, is the perfect example of code that's easy to delete. It's this add function. And why is it easy to delete? If we invoke this and execute it, for instance, with the arguments 1 and 2, we get 3. We could easily replace this in our system to the execution result itself, the invocation result itself, and now we haven't affected the system at all. The code before and after this is exactly equivalent because it doesn't affect the system at all other than the result it gives. And this also means that in this context, add is totally deletable without ever having a fear to affect our system in a negative way. So this is a deletable code because now this is also exactly the same. all those 4 lines is the same as this, given that you don't use this in another context. So let's look into what makes this so deletable. And it's, first of all, something I've put quotation marks here. It isn't necessary to understand like the terms of things, but this is something that we often call in functional programming world pure. Because the only way it can affect the system is by returning something. The only way it interacts with the system is by taking something in with its parameters. There's no global context, there's no state, there's no I/O, there's nothing other than what it actually does. It's add, and that's it. And that's also making it a single responsibility thing. So this is add, it does add, nothing more. It's also composable. You can combine it into different things. For instance, I could easily use add twice to make a new add that has an arity of 3 instead of 2. And now I've just combined one simple thing to make a bit more complicated thing or a more complex thing. So like this, we can build stuff with composability instead. And what's interesting with composability in this matter is that it's an infectious trait. So a component consisting of purely pure functions is also pure by itself. So that means it stacks over time. So the product of a function that's pure, if the first function is deletable, the second function is also deletable. So it propagates the properties. Of course, add is a classic example. It's rarely used the world's most boring calculator, so we'll look into more interesting stuff. This is, I think, again, it's a lot of code. You don't have to read the entire code block. It's just an example. But it's something we can often see. Like, there's some sort of I/O. It's something that fetches some data and then converts or projects the data in different ways, resulting in something. So just to abstract this, it's often separated into 2 parts. We have the state or the I/O or whatever that goes outside the function itself. And then often we have some sort of thing that's converting the data and transforming it into different shapes. And another problem here is, one thing is the mix between the colors here, but also if you look closely at this part, it's very hard to understand what's going on. It's easy to write, and you can kind of understand it just by reading at it, but the most important part is I have to go through the lines and read everything that's there. So I can kind of decipher that, okay, it's some type of filtering, so it's sorting by some rating, and then it's some accumulator, okay, so it's kind of a group, or a group by. But it's hard. Every time I read this, I have to manually go through, parse it in my head, try to execute it. There's a syntax error, stack error, but whatever, and then we can sort of decipher what it does. But it takes a lot of time, and it makes me uncertain when deleting this, have I affected the system in a way that's not apparent, because it's not isolated enough. We can improve this to make it more deletable. So seeing the entire function here again, if we're just, again, it's not important to read. We'll look into the properties of this. But we can separate it into 2 different functions, where one is entirely pure, and the other has those things that makes it harder to delete. So things, again, state, I/O, things like that, having some sort of effect on the system that we don't control. So while doing this, we have the same properties as with the add function. The only way it interacts with the system is by parameters, and the only way it affects the system is by its return value. This also classically makes things easier to test, even though if you prefer end-to-end test, it's always nice to have the ability to do things like this. If you look into the details here as well, now we're taken the time to actually name things. So the function itself is a combination of several other functions that's easier to mention or to describe without having to use a lot of ands. So you just say merge pasta and rating. This is a different and because it doesn't like group concepts, but it's two different entities that it's supposed to merge, whatever. A group pasta by rating. So that's named concepts that are more clear in intention and how it affects the system. And they, again, have more specific responsibilities than the overall function, so it's easier to read, and when the intention is clearer, it's also safer to delete without being afraid of destroying something. And again, because of the infectious trait of purity, the entire function is pure as well. But of course, now we have a lot more code. This breaks with my initial principle of not writing code. But I don't think it's important to focus on brevity here. We're focusing on optimizing for deletion, which is an entirely different thing, and we can be both have not too much of brevity and still be clear. And there's a trade-off there. But in any case, we now have more functions, so where should we put them? The simple answer is as close as possible. But let's look into why. For the keen eye, you can also see that spaghetti is a very hard word to spell. So there's somewhere across the examples here, there might be some spelling issues of spaghetti. But a common and traditional way to structure code is layered like this. So in a way that's oriented around separation of concern. So we have our components or whatever, we have some models, we have some routes, it could be controllers, it could be pages, it could be services, whatever, but it's separated by some sort of concern. And this structure has its advantages because you're grouping things that has something to do with each other, like concern, what type of problem they solve. But when optimizing code to be deleted, there is also some obvious pitfalls there. Because you depend on code that's further away from yourself, and the more peripheral any code is, the harder it is to remember that it exists at all. So in this case, you would have to do a lot of cross-references between different structures that are entirely different spaces in your hierarchy. So when evolving code bases over time and trying to do deletion, it's hard because you will have a lot of different loose data that's not relevant anymore. But also, you can do some statistically analyzable tooling to remove dead code in a sense, but that's harder to do if cases where you have like dynamic imports, lazy loading, and whatever. So it's harder to discover all deletable code when it's more distanced from where it's consumed. Another traditional way now, I would argue, a more common way in modern architectures, at least on the web, is, and also in other on other services, I guess, but is grouping by semantic relationships. So this is often also commonly referred to as feature folders. I think it's more nuanced than that, but in modern front-end architecture, at least, this is now very common. So instead of grouping by concern, we group of what part of the domain the code touches. So I don't like to call it feature folders because it's more domain-specific or more domain-semantic relationships. So it's grouped by domain instead of features. So that means, for instance, macaroni has its own things. The pasta administration unit has its own thing with the components, and that's only relevant for that specific thing. That's not to say that it's not possible to reuse things, and that every of these domains grouped folders should have their own versions of things. Of course, we can reuse things, but it changes our mindset to think code proximity first instead. So if you need a helper function, you should start by having that helper function as closely as possible, even on the top line or without the specific function down below. But you could also think like reusability second. And I think this is a good principle in any case, in any system, because more often than not, I would argue, you see that most of the helper components or helper functions you extract from your code is never reused. So don't start by making things generic. That's hard for making things deletable. So I would argue more likely than not, you will not reuse it. And it's just as easy to make things reusable after the fact than in front. So it's a win-win scenario in my mind. I like to think of file structures as separate modules, not only structures, but again, they group by semantic meaning and domain. So all code within that touches that domain should be as closely as possible. Things utils, APIs, services, components, data layers, mappers, whatever, should all be placed in the same, as long as they are part of the same domain. So not the role they play by in layering. And I think this is more important as systems grow, because it's easier to forget code or easier to understand code, and also having a strict relationship with this makes it easier to navigate the code. So for instance, if there's a chunk of reusable code that you want to transfer it to its own module, it can have its self-documentation, it can have its own test, it can have everything that's required of that. Having that, so if it's no longer needed, that's removed from the domain or removed from the use case, you can delete the entire module. So this isn't any new, of course, but being strict on this and being strict on if you have to remove or have to reuse something, trying to move it to the least common ancestor, and thinking of it as a clean, specific, explicit API itself is important, and thinking dependency graphs. Because it's easy to do a hybrid solution, which is kind of, yes, we have this, but it's also a lot of concerned things on the top there, so it's kind of a mix bag with that. So, and also thinking relationships there and thinking edges between those modules. It's important to think of as directed edges, not duplex edges, so they shouldn't communicate, because that's a big ball of mess then, because you don't have control over where the data flows. So these separated modules should have explicit, concrete APIs, and think API change when you use them. That means they should have some sort of privates, so that you're not exposing. And for not exposing code, you can do whatever you want. You can break the APIs as much as you want. But thinking explicit versioning or handling APIs on modules that cannot have easy breaking changes is important for this to succeed. And again, even though in modern web architecture we use a lot of feature folders now, it's also as common to have some sort of implicit hybrid structures in a sense. So it's kind of feature folders, but we have some sort of things that's reused up there. So specifically domains types or types and interfaces or whatever often is shared. So that can have some major implications to your code and making it more tightly coupled in a bad way. And that also breaks in some way the principles of domain structures. Ideally, those modules I was talking about should have some sort of like bounded context, meaning they should have their own types and do conversions between those to be safe for that. But I found that often in larger projects that can be hard to do. So this is attacking that from a different angle in addition, so kind of a middle ground. But this is not uncommon to see in codebases, I would argue, where you have this avatar that operates on the user, and in reality, the signature says, I'm an avatar and I take a user, but inside the implementation itself, it only uses avatar and the name. So it's kind of I like to call them greedy components or greedy functions. They ask for more than they actually need, and it washes out the importance of the API. Because when we see it from a consumer standpoint, it seems like it takes the entire user object, but in reality, it just uses some parts of it, but that's masked for us. So it's from an easy perspective, it's hard to see. So it's convenient, but it's not deletable. And I would argue that it causes a lot of misunderstandings and again, breaks the entire concepts of explicit APIs. A consequence of this is that like I said, you're coupling a lot of different parts of the code by a third entity, and it makes for a hybrid domain. The domain modules are not as explicit and as clean as before, because you have this shareable instance that's used everywhere. So what happens over time is that it's very hard, when used several places, it's very hard to be certain that if I change this name now, it causes an change in 40 other files. So I won't do it. So I just perhaps introduces a new field that's backwards compatible, and then I change it over time. And over time, this will grow as a big black hole and consuming the entire code base, and you are afraid to touch it, and you have to rewrite your entire code base. So a different way of thinking here is bottom-up modeling. So instead of defining what can I access, you can say, this is what I need, and it's more explicit. A lot of people have some issue with this because it feels like noise, because you have to pass in the parameters and properties specifically. But it's arguably more explicit, and it's clearer that avatar uses some sort of avatar and a name for that. If needed, you can have a compromise and use the properties of structural typing in TypeScript to just say, I need an avatar user, because it's not a user, it's an avatar user. And that has an avatar and a name. And now we're just as explicit. We can pass in the name, but using structural typing, that it can use a subset of it as long as that's matching. I think this can be a good compromise, because it's still explicit, but it still has some drawbacks when tightly coupling to a model. So now we have talked about domain modeling, composability, and pure code with single responsibility and structuring by proximity first. So we'll try to put the entirety in one example with somewhat realistic piece that's fit on one page. But for that, I think it's important to again see that more lines doesn't equal more complex necessarily. And I argue that clarity and intention trumps brevity for brevity's sake. So brevity has, there is value to brevity and shortness in a way, because it's less to read, but also it's easy to misuse. So it's always a trade-off on how much to use it. I'm warning you, it's not important to read this, but it's a lot. But this is a very common example in React. It's true for most component-based frameworks and libraries, but I think using React as an example is valid because it's widely used. But again, it's not important what it does, but it's a form for rating pasta types based on different types. So when rating ravioli, you have to rate explicitly the contents of the ravioli. Well, if it's just spaghetti, you can rate spaghetti as a whole. So it's just an example of a component that you might see. What's more important, I think, is often in these types of components, you'll see them split in two. So you have the setup part that has some state, some effects, does something, and you have the view part. And both of these have the tendency to grow outside of what's actually needed. In this case, I've also added a ternary inside a view, because that's also very common to see. But And I can understand why, because ternaries are expression if-elses, so they're easy to use in place. But it also causes a lot of confusion and components to grow outside their single responsibilities. But we'll look more into that soon. So let's look at the setup part. Often you'll see something like this. You have some sort of state and you have some sort of effect. Again, this is a React-specific example, but it's relevant for all other cases, I'd argue. So what you often see is that you do some effect on some type of ID and do some fetching for that. But that's, if you look closely, you have very like two grouped types of code. So if you have the setup, in the setup you have the state itself, and then to populate or enrich that state. But those are loosely coupled in the entirety of scope. So everything other that's in the same scope knows that it's there. So it's, you have no other explicit relationship between where it's used and where it's created. It's just an unsigned contract between those two parts. And the entirety of the scope, you have to think, what is that? Oh, yeah, that's just used there. It's just plain noise. And it's hard because, like in this case, you have some sort of setup and you have some sort of actions or interactions. And this is a generous example because often you have a lot more setup, a lot more types of state, and you just have a big ball of mess that's intertwined implicitly without having control of what it is. So here it's easier to see, perhaps, because I color-coded it. So the brighter parts are relevant for each other, and the darker parts are only relevant for each other, and it's not as relevant further down the code. Now we learned that a simple way to handle this is by abstract and isolate. So that's an easy part to do. In this case, by a custom React hook. It could be a function of any type of sort, but suddenly the only thing we need to think about is the pasta details that's returned based on some pasta ID. It's more, has isolated the complicated parts and just shows us the relevant parts from a consumer standpoint. It's a small thing, but it's often very underused in code bases. The color coding here is the same. So this does the exact same thing, but it's the intention of what it does and how it affects the system is much clearer. Further down in the setup code, we often have things like projection of data. So we get some sort of data from somewhere, but then we have to say, okay, but if it's this type, maybe we have to show this. If it's a name for that, we have to show that. So we're changing, transforming data, and showing that you can set up code for viewing further down the component. Note that this, for instance, is only relevant for ravioli, and then we have the same issue as before. And this, again, very common in code bases, especially in component architecture code bases. So in this sense, the variable, I like to call it a loose variable because it's loosely typed with some sort of implicit contract. It's only ever relevant for ternary case 1. For every other cases, it's just noise. And this, again, is a generous example because often in code bases you can see like 3, 4 types of these loose variables that crosses. Some of them are used in both ternaries, some are just used in one. So the permutations of how it's used is hard. So it's making we're making the job difficult for ourselves just by being lazy. The solution is, as before, abstract and isolate. So taking just and writing custom components for those two specific cases, it hides the details within it. So now, instead of, yes, we still have to do is ravioli because that's a factor from that component itself. That is the responsibility of my main component in this sense. But then I pass it on to ravioli pasta, and within that, I do all the transformation and projecting of data that's relevant for that part. We can also look more into like the spaghetti pasta component, which is the same, but it's again, has some sort of logic within it, so we don't have to do nested logic, then making a lot more indentations that it needs to be in the original component. And again, we have named concepts here. So that's a very important part. Naming is always an opportunity to state your intention. So it's also, it adds value, it adds context, it adds communication for yourself, for the present and the future. So this is arguably, you can see what makes this, what this consists of without having to visualize it manually in your mind if it were not abstracted to its own function. Here we can also see the bottom-up modeling, because we could reuse different types here. I've used spaghetti type that's created within that context, but we can also, as it essentially uses the same, it uses the same property as the other component, we could reuse that, but that would tightly lock in them, and it's harder. We're making it more difficult for ourselves to do changes that's specific for them. So it's harder to evolve, and it's more tightly coupled. So it's, again, harder to delete. And it's also it's a strength to have an explicit API like this, because, again, it can evolve individually. What's also interesting here is that if you look into the way we're doing it now, it's more separated from what's pure, what's without any I/O or whatever, and what's actual state and I/O is on the top, and it's explicit by only using parameters and arguments further down, and the return of it is the only way it affects our system. So this is the same as refactor as we did initially. And it's still relevant for all types of components in front-end libraries, is that the infectious trait of purity is still the same. So a component consisting of other pure components is also always pure, and therefore also deletable. I've talked a lot about abstractions, and also see that I've abstracted when it was needed, because abstraction in programming is a powerful tool, but it could also be misused. It's easy to overshoot and start with a high level of abstraction, but it's always easier to go to a higher level of abstraction than to the vice versa. So going to a lower level of abstraction is harder, and it feels more restrictive, because it has always the risk of regressions. So compensating for the wrong abstraction often costs more than not having enough degree of abstraction, is my point. And this is also why it's important to not make everything generic from the get-go, because that's an abstraction that you often don't need, and you have to maintain that abstraction as well. So to summarize, we have to tackle unintended complexity. So that's complexity that doesn't follow the domain itself. And we have two ways of handling that: abstract and isolate, and remove. So code is communication. It's more for the future than to the machines itself. Communicating to machines is often the easy part. But we should also have some sort of dialogue and conversation within our teams to see what are our goals and non-goals in how we're structuring code, so we're on the same page and know why we're doing that, instead of having dogmatic rules. So that also means take time to think about why and how, not only this is the rules and you have to have cyclomatic complexity below 8 and whatever line of code you want. So another thing is naming things. It has the power. Use that power. So don't optimize for productivity exclusively while writing, but for reading and maintaining over time, and optimize things for deletion. So a ravioli system, it's a system that's optimized for eating or deleting it if you want. That's it. This is a blog, but before you go, we have a live podcast today at 7. There is a questionnaire that's very, very relevant for the quiz and the live podcast. So please take the time to scan and answer that, because it has an effect on the live show later today. Thanks.